couple more notes about z-score. If you are below average, if a point, I should say, is below average, then that point will have a negative z-score. So this person is, the average is 75, this person has 74, so that particular point minus the average divided by standard deviation is negative 0.5. This person is half a standard deviation below the mean. And you can also calculate their percentile, and I'm not going to bother doing that again. Instead, I want to talk about transforming a distribution and how that affects percentile and z-score. Let's take this person, right? They got an 80, and the teacher looks at the class average of 75 and says, I'm going to give everybody 5 points. This person used to have a z-score of 2.5, used to have a grade that was significantly above average. How will their z-score be affected? Their percentile used to be 89th percentile. Will that be affected? Well, let's have a look. If you raise all grades by 5, you'll find that that person is still at the upper end, is still higher than the same percentage of people. So transforming a distribution by adding something to every one of those points doesn't change percentile. And that's why it's a decent measure of where you are compared to everybody else in your distribution. Same thing for standard deviation. Standard deviation hasn't changed. All the points got moved to the same distance. The gaps between the points haven't changed. The average distance from the average hasn't changed because now the new average is 80. These points are still 1 away from it. This point is still 2 away from it. This point is still 5 away from it. So, the standard deviation hasn't changed, and the calculation for z-score would stay exactly the same. Take the point, compare it to the average, divide by standard deviation, 2.5. So your z-score and your percentile are not affected by transformations that would add a number to all the grades. And that's why no one complains when the teacher says they're going to scale the grades, because your position relative to the rest of the class hasn't changed. Nobody gets set further behind or further ahead. Now let's take a look at, then everybody else. It's just, Let's take a look at a different sort of transformation. What happens when you multiply by something? Let's take a look at this. Imagine that your teacher says, this test is worth 10% of your overall grade for this term. So everybody starts calculating how many points they've earned. This person has earned 7.3% of their term grade. This person has earned 7.4% of their term grade. 7.4, 7.4, 7.5, 7.5, 7.5. Has the standard deviation changed? Yes. It will have changed to 0.2. So let's take this person. This person used to be in the 89th, percentile. Are they still in the 89th percentile? Yeah, they're still above 89% of the distribution points. Is their z-score still 2.5? Yes, it is. 8 minus 7.5 over 0.2 is 0.5 over 0.2, which is 2.5. But I can explain why this happens in theory also. If you take a point and compare it against the average and then divide it by the standard deviation, you know what? I'll use what they're using here. Let's say I multiply everything by 2. All the points get doubled, or divide everything by 10. Let's just say I multiply it by something I will call a constant. That also, as well as multiplying every point by a, and it'll multiply the average by a, and it'll multiply the standard deviation by a, because when you divide everything by 10 or multiply everything by 10, the points will get that much further apart. A gap of 1 will widen into a gap of 10. And so then, no surprises, you can factor a out, and cancel out the a's. Oh look, the formula for standard deviation isn't affected when you multiply everything by something. How about adding or subtracting? Well, when you add or subtract something to an entire distribution, let's say everybody's grades were scaled by 5, a individual point has a certain number added to it. So too does that same thing happen to the average. The average also grows by the same amount. How is standard deviation affected if all grades rise by 5? It's not affected at all because everything is just as far away from each other as they used to be. So standard deviation isn't affected. And then this is positive b and this is negative b and they will cancel out. Yeah, so basically the formula for standard deviation, if you look at the formula you can see when you do this sort of math that your location in the distribution as measured by z-score won't be affected. And that's what makes z-score such an effective measure of where you are compared to everybody else. You can find, yeah, your location isn't dependent on what the particular numbers are. I didn't say that so well.